In order to understand cryptography, first we need to understand the basics of some numbers. By numbers in the sense, we need to understand what is a natural number, whole number, prime number, and other types of numbers. We also need to understand what is modular arithmetic and how to find mod of any number. First we'll see what is a whole number. Whole number is any number without a decimal part. So as you can see, that number should not have any decimal part. It includes all non-negative integers. It is just like the numbers 0, 1, 2, 3 and so on. Next we'll see what is a natural number. A natural number is any number that is greater than 0. So as you already know, it starts from 1, 2, 3, 4 and so on. So natural numbers, they are also called as counting numbers because this is how we start to count 1, 2, 3, 4, 5, isn't it? Next we'll understand what is a factor. A factor is another number which divides a number evenly. Evenly in the sense it should not leave any remainder. As you can see, it should divide the number but we should not be left with any remainder. We can also tell that when we multiply this number, we should get the other number. We'll see some examples. See, for example, in order to get 8, you can multiply 4 and 2. So 4 and 2 are factors of 8. If you multiply 1 and 8, so we will get 8. So 1 and 8 are factors of 8. So total, so which are the factors of 8? 1, 2, 4 and 8. Next, in the cryptographic world, one of the most important number is prime number. So we'll understand what is a prime number. See, prime number should not have factors for 1 and itself. See, in the previous example you saw, see here 8 for example. Is 8 a prime number? No, because see here 8 you can get it by multiplying 4 and 2, isn't it? So this condition does not hold. It should not have any factor except for 1 and itself. See, 1 is not a prime. So can you tell me why 1 is not a prime? Because it does not have two distinct factors. Two different factors should be set. See here, if you want to get 1, you need to multiply 1 and 1. So here also we have the same prime factor, here also you have same. So the factors should be different, like this, 4 and 2 or something like that. See here, 2 is a prime number, 3 is a prime number, 5, 7, 11. So this number keeps on going. So if you want to get 3, we have only one way, 1 into 3. If you want to get 7, we have only one way, 1 into 7. See, as I already told you, 1 into 1. Next we'll see what is composite number. So any number which is greater than 1, having more than 2 factors. That is number that are divisible by more than 2 numbers. See, for example, 4, 6, 8, 9, 10. See here, factors of 8 are 1 into 8, 4 into 2. So total 8 has factors, 4 factors. So as you can see, this condition is satisfied, more than 2 factors. Now, so this is very important with respect to the exam. So in the exam they'll ask, so they'll give you 2 or 3 numbers and they'll tell you, find out the GCD of these numbers. So GCD stands for greatest common divisor. So what is a GCD? A GCD is a number which should not be 0, that is the first condition. Next, it should be the greatest number that multiplies both the numbers. So don't worry if you don't understand, in the next page we'll solve some problem and try to understand. For example, let us see how the GCD of 12 and 8 is 4. See, we don't know whether the answer is 4, 3 or 2. So we should start from the beginning. First we'll divide both 12 and 8 by, we'll start from 2. So 2 into 6 is 12, 2 into 4 is 8. Okay. Next, we'll go to the next number which divides both. See, 3 does not divide, see 3 into 4 is 12, but so 3 does not divide 8, so we'll go to 4. 4 into 3 is 12 and 4 into 2 is 8. So there are no other numbers which divides both 12 and 8. So out of 2 and 4, which is greater? 4. So the GCD of 12 and 8 is 4. Now, so the method which we saw is called as division method. So because we are dividing and then we are finding the answer. Now, we'll find out the GCD of 30 and 45 using division method. First what we'll do, we'll start to divide. See here, 30 divided by 45. So 30 into 1 is 30. So the remainder is 15. So then what we'll do, we'll start to divide this. 50 into 2 is 30. So the remainder is 0. So the GCD of 30 and 45 is 15. So which number should we take? So what number, when we divided we got 0, that number we should take. As you can see, when we divided 30 by 15 we got 0. So that's why 15 is the GCD. So the answer is 15. Now what is GCD of 442 and 546? We'll see. As you can see, 442 into 1 is 442, the remainder is 106. Again, as I told you, you start dividing here. 104 into 4 is 416, so the remainder is 26. Then again, you start from here. So 26 into 4 is 104, the remainder is 0. So now you know the answer. What is the answer? The GCD of 442 and 546 is 26. Now, can you try what is the GCD of these three numbers? So in such cases, what we'll do is, first we'll find out the GCD of any two numbers and then the answer will find out the GCD with the next number. For example, let us say we'll take 546 and 424. So these two numbers we are taking first. Any two numbers you can take. So 424 into 1 is 424, the remainder is 122. Then again you bring it here. 122 into 3 is 366, so the remainder is 58. So this number you bring it here. 58 into 2 is 116, so the remainder is 6. So this number you divide. So again, so if you divide, you will get the remainder as 4. So in the same way, if you bring 6 here and if you continue, the answer will be 2. So you can try for yourself. You will get 2 as the answer. Now, we should find out what is the GCD of 2 and 442, because the GCD of 546 and 424 is 2. So the remaining number is 442. So now let us find out what is the GCD of 2 and 442 by division. If you divide 442 by 2, we will get 221, the remainder is 0. So the GCD of 442, 546 and 424 is 2. Now one more important aspect, we will see what is co-prime numbers. See, this is very important with respect to cryptography. So co-prime numbers means, so numbers which have a set of numbers which have GCD as 1. For example, see 7 and 8 are co-prime. How do we know that they are co-prime? Because the GCD of 7 and 8, if you want, you can try. So the GCD of 7 and 8 are 1. See here. And one more important property is 1 is co-prime with every other number. So any number you take with 1, if you take with any number, it is co-prime. See here, 1 and 8, they are co-prime because GCD is 1. 1 and 10, they are co-prime because GCD is 1. And one more important property is prime numbers are co-prime to each other. If you take any two prime numbers, they are co-prime because for example, if you take 3 and 5, both are prime numbers, their GCD is 1. And one more important property, any two successive numbers are co-prime. For example, 17 and 18, the GCD is 1. And one more property, the sum of any two co-prime numbers is always co-prime with their product. For example, if you take 2 and 3, see 5, see 2 plus 3 is 5, and what do you get if you multiply 2 and 3? 6. 2 plus 3 is 5, 2 into 3 is 6. So 5 and 6, they are co-prime because the GCD is 1. That's what this says. The sum of any two co-prime numbers is always co-prime to the product. So 5 is the sum, 6 is the product. Now I will give you some exercise. Can you identify the co-prime numbers here? See here, 24 and 36, they are not co-prime. You try it by yourself. 20 and 21, so this is easy because these two are successive numbers. Next, 542 and 446. You try. So this will not be co-prime numbers? You let me know in the comment section. Next, we'll go to the important thing, modular arithmetic. See, modular arithmetic means, so it is defined only for integers. So it is mainly dealing with the remainder. So how much do we get after we divide? What is the remainder? And in modular arithmetic, one important thing is all the numbers wrap around. So I'll tell you what is this in the next slide. See, for example, if you take the example of a 12-hour clock, see, all the numbers are integers here. See here, 1, 2, all the way till 12, all are integers. See, after reaching 12, so there is no 13 here. We come back to 1, isn't it? So after reaching 12, we come back to 1. That's why we say numbers wrap around. For example, if the time is 9, so if I ask you to meet me after 2 hours, so that means, see here, after 2 hours, 1, 2. So you meet me at 11. See, for example, if I tell the time is 9 o'clock, so meet me after 6 hours. What will you do? See here, 1, 2, 3, 4, 5, 6. That means you meet me at 15 hours, isn't it? But there is no 15 here. So instead of 15, what we have? We have 3. That's why it says 15 mod 12 is 3. So 15 is same as 3. That is the meaning. 15 mod 12 is equal to 3 means in a 12-hour clock, 15 and 3 are same. So that is what they are trying to tell. Now can you try to do this exercise? What is 18 mod 12, 24 mod 12, 32 mod 12, 4 mod 12 and 8 mod. So let me know the answers if you don't get it. Next we'll come to congruence. So as I already told you, after 13, the numbers they are wrapping around. So instead of 1 we have 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, isn't it? So the numbers they are wrapping around. That means in a 12-hour clock, 15 is congruent to 3. 15 is equal to 3. So in a 12-hour clock, 15 is as good as saying 3 o'clock. So 17 hours means it is as good as saying it is 5 o'clock. So we can write in a 12-hour clock, 17 is congruent to 5 mod 12. That means in a 12-hour clock, 17 and 5 are same. In a 12-hour clock, 15 is same as 3. That we will write it like this. 15 is congruent to 3 mod 12. Now we will see some important properties of congruence. So you please write down this. So all these formulas we are going to use in the next. So A is congruent to R mod n if R is the remainder obtained by dividing A by n. A is congruent to A mod n. A is congruent to B mod n, which implies B is congruent to A mod n. A is congruent to B mod n and B is congruent to C mod n implies A is congruent to C mod n. Now we'll see what is the modulus of a negative integer. See, 3 mod 12 is 3, 7 mod 12 is 7, 13 mod 12 is 1. Now what is minus 3 mod 12? See, minus 3 mod 12 is 9. So in order to find the modulus of a negative number, we have a small formula here. See here, minus n mod k is equal to k minus n mod k. So you can substitute here. See here, in place of n we have minus 3. So in place of k we have 12. So what is the answer? See, 12 minus what is n? 3 mod what is k? 12. So what is 3 mod 12? So 3 mod 12 is 3. So what is 12 minus 3? That is equal to 9. In the same way you can find out what is minus 3 mod 17. You will get 17. You can try to verify it yourself. Now we will see some properties of modular exponential. So if there are two numbers a plus b mod n, you can write it as a mod n plus b mod n mod n. So in the same way, a minus b mod n is equal to a mod n minus b mod n mod n. In the same way, it is for multiplication. A into b mod n is equal to a mod n, b mod n mod n. So all these things we are going to use in some problems. Now let us see how to find out 3 square mod 5. What is 3 square? It is very easy. So 3 into 3 is 9. So 9 mod 5, when you divide 9 by 5, you will get remainder as 4. But how do we find out 3 to the power of 4 mod 5? So this also you can write it like this. See, 3 to the power of 4, you can write it as 3 square whole square mod 5. So 3 square whole square mod 5 can be written as 3 square into 3 square mod 5. So you can look at the previous slide. So this you can write it like this. So you can multiply and you can expand it like this. So in the end, we already know what is 3 square mod 5. It is 4. So 3 square mod 5 is 4. This is also 4. So 16 mod 5. So 16 mod 5 is 1. In the same way, you can try to find out like this also. 3 to the power of 8 mod 5. You apply the same formula here. In the same way, 3 to the power of 10 mod 5. Again, you apply the same formula here. In the same way, you can find out mod to any numbers. 3 to the power of 20. First you divide it, so 10 plus 10. So then you apply the formula. You will get the same answer. 2 to the power of 34 also. So all these problems are same. So you can try to solve it in the same way. 2 to the power of 32.